Here's a leveler. So this is the leveler right here. You can see for the device entirely. So if I move this, as I rotate this, you can see the bubble kind of needs to go down. It's about where it needs to be. Okay. Leveler. Then you see this really interesting thing. This is a spring. This is the part that's going to measure the tension in the water. But an interesting thing about the spring is its capability of resonance. And I can just do that and it will stay that way for quite a while. Barely losing any energy at all. And that's important for also the mechanism to operate, is for it to be able to do that. So the fundamental way of how this operates is there is a spring here with a ring, like a circular ring, open, kind of like a torus, and there would be a cup or something of water or some kind of liquid right here, and you would slowly dip this ring into the water right on the surface. And then you would use this dial, or sorry, my bad. And then you would use this dial right here to adjust away from the ring. And this dial pulls at this string right here and pulls this upwards, making it want to pull away from the water. And from that you can measure tension. And from that you can measure tension. So it's kind of not super hard to do. Here you have this mirror for leveling right here, using the mirror and this. And here you have this adjustment knob right here, which you can adjust how close where you want your thing of water right there. And then you can also have this finer adjustment right here, which is a little more fine. So just a coarse adjustment, and that's pretty much the mechanism. It's like dipping a bubble blowing wand. So that's pretty much the mechanism. It's like dipping a bubble blowing wand into some kind of surface and then pulling that away and then calculating the force somehow from that. That's pretty much it. That's close enough, okay. Then, okay. Again, it was below the line, I think. So since it was below the line, it had a little more tension, so you can subtract that off of that. You could probably get around 77 dynes per centimeter. So there, but it should be about there.